Hello everyone and welcome back to another microeconomic lecture. Today we're going to be talking about production in the long run. So when we talk about the long run, what are we talking about, right? In the long run, all of our factors, right? All of our variables of production, including capital, all of these factors are variable. So instead of the production function being something that's just Q is equal to some function of labor, right? Now we have Q is equal to some function of labor and capital. Since all of the factors are variable, the conclusion of this is that the long run production function which, is, in other words, this thing, right? Our long run production function shows us the most efficient way to produce any level of output. And so the long run, right, it's a period of time where all of the costs are variable. And in the long run, we're going to be making certain decisions. Because of the fact that capital is variable, there are going to be different production technologies. And these production technologies are essentially just alternative methods of combining inputs to produce some output. When we're talking about the long run, one of the main things that firms are trying to take advantage of, if they can, is something called economies of scale. So economies of scale is a specific situation where, as the quantity of output increases, the cost per unit also, or sorry, doesn't also, but as the quantity increases, the cost per unit decreases, right? So the more we make of this, the cheaper it is to produce. Economies of scale graphically would look something like this. Where we have different points here. Over here is our average cost of production. And this is in dollars. And then down here, we've got our quantity of production. And so we find that if we have 1,000 units produced, well, we're going to be at this point S. And at this point S, the average cost of production is going to be $12 per unit. However, since we are in a situation of economies of scale, if we were to increase to 2,000 units, then we would now be at point M, and the costs, right, the average cost per unit is decreasing from 12 to 8. Furthermore, what if we were to increase it all the way to 5,000? Well, we find that at 5,000 we're at point L, and at point L we have an average cost of 4. So significant cost savings by increasing the amount of quantity that we produce as a firm. So why do these exist, right? So the question is, why do economies of scale exist? And the answer is because larger scales of production typically lead to lower average costs. When we're talking about costs in the long run, one of the things that you'll see in the textbook, and you'll also see, fairly uniform, fairly everywhere throughout the internet, is talking about what's called the long run average cost curve. So let's go ahead and define that. So long run average cost curve. So this is abbreviated as LRAC, and this is going to show us the lowest possible average cost of production when we allow for all inputs to vary. And so once again, what is allowing all inputs to vary mean? This means that the firm is choosing its production technology. Okay, we're going to make these cars. How many of the processes are going to be handled by automation and robots, and how many of them are going to be handled by workers, right? So that's just a simple case of talking about different production technologies. Now, how are long-run average cost curves created, right? It's a great question. Well, long-run average cost curves, and we'll see this in a second in terms of the graph, but long-run average cost curves is nothing more than the lower envelope of your short-run average cost curve. So let's go ahead and get that down here and defined as well. So the short-run average cost curve, also, SRAC, is the average total cost. So we know that that can be abbreviated by ATC, right, from our lesson last class. In the short term, and essentially this average total cost is going to be what? Nothing more than the addition of my average variable costs and my average fixed costs. So that's just kind of a side note there. So what does this all look like, right? Great question. So if we have a firm that has a choice of, we'll just say 5 different production technologies, it's going to look something like this. We have cost on this axis, and we have output on this axis. And we're going to go ahead and do our short-run average cost curves first, right? So essentially, if we expect production to be relatively low, we might have a technology where the short-run average cost curve is right here. let's say that we expect, there to be more output than this, right? This is going to be, we can just kind of start labeling this. This is going to be our Q1. Let's say that we expect more output than Q1, right? So we are going to be on a different production technology when we talk about SRAC 2. And again, this is going to be related to some quantity around Q2. And so on and so forth, right? There's another one that's right here. As we increase our output to the more extreme amounts, starts to look like something over here, starts to go back up. And again, all of these equate to, some range of output. But the thing that is important in this whole exercise is that the lower envelope, right? So I'm just going to trace along the bottom of this. That is how we get our long run average cost curve, right? Because what's actually going on is that it's not just, these 5 different technologies, right? There's actually more nuanced kind of short run average cost curves that are, happening in between, right? So there's really a bunch of different short run average cost curves. And so this lower envelope of all of the short run average cost curves is what creates our long run average cost curve, right? It's the lowest cost for producing each quantity of output when fixed costs can vary. So the long run average cost curve is going to be formed by using the bottom edges of the family, right? The group of short run average cost curves. And the shape of these long run average cost curves tells us different things, right? So, it's going to tell us how many firms are going to compete in that industry, right? It's going to tell us whether the industry might have different sizes or whether they're going to tend to be the same size, right? So real quick, let's just do an example of 2 different long run average cost curves and the inferences that we may make as a result. All right, so we've got cost or dollars up here. We've got output or Q down here. And so if we have one long run average cost curve that looks something like this, well, there's a clear minimum point here, right? There's a clear minimum point that at 10,000 units of input, the average production is going to be $500 per unit, right? So this is telling us that, well, everybody is going to produce at this point R, right? There may be some other points over here, there may be point P or point, X, right? But everyone is going to be producing at R because it's the clear minimum point. Any firm that's producing at a different quantity, right? If you were to produce at 5,000, you'd be paying more than $500 on average. And if you were producing, 15,000, you'd be paying more than 500 on average, right? So that's no bueno. Now compare that to something that looks right here. So long run average cost curves can also look like this, right? In this case, this is what's called a flat bottomed long run average cost curve, right? And the firms can essentially produce at any of the prices in between these, or not prices, but rather any of the quantities in between these points, right? So they could produce from 5 to, 20,000, and they're all going to essentially have that same 500 average total cost. So firms producing less than 5,000 or greater than 20,000 are going to face higher average costs and then be unable to compete. All right, I hope that helps. Please go ahead and comment or send me an email with any questions, comments, or concerns.